Welcome, ladies and gentlemen, to NGR's third webinar in this year. My name is David Henberger and I'm responsible for the PET product management at NGR. After the post-industrial and post-consumer webinar, it is a pleasure for me to guide you through the PET webinar today. The topic today is PET recycling with first-class decontamination technology. During the webinar and 30 minutes afterwards, our chat is open. Please use this opportunity to clarify all your questions and thoughts. What can you expect from today's webinar? First, I will start to give you a quick overview about the company NGR itself, followed by a short introduction of the Lsp Technology. After that, we are coming to the main part of the webinar today, the walkthrough of the bottle-to-bottle line in our demonstration center. Finally, I have prepared an interview with one of our first bottle-to-bottle customers, the company Altech from Japan. NGR is a member of the Next Generation Group, the only technology provider representing the entire product lifecycle. NGR produces machines for the post-industrial and post-consumer sector, as well for the recycling of all kinds of PET materials. Further, we have the company Colin in the group. Colin produces extrusion lines for the lab and medical applications, such blow film lines, multi-inspection system, or the online viscosimeter, what we are using in the P-React for the control of the intrinsic viscosity. A further member is Britas. Britas produce automatic band melt filter solutions, mainly for the post-consumer applications. Finally, we have NGE, Next Generation Elements in the group. NGE produce pyrolysis systems for the production of fuel gas and coke out of various different non-recyclable materials. The headquarters from NGR, including development, design department and manufacturing, is located in Upper Austria. Further, we have a sales warehouse and a customer care center in the US and Malaysia, and a sales office in China. NGR was founded in 1996 with the target to simplify recycling technologies for the plastic manufacturers. Developing, design and manufacturing is done by approximately 160 employees. We have over 1,400 machines installed in over 100 countries around the world. As mentioned, NGR provides machines for 3 different sectors: post-industry and post-consumer recycling, as well for the converting of all kinds of PET materials. Each section has its own individual challenge, what we gladly face every day. NGR started in 1996 with the development of the S-Gran, the shredder-feeder-extruder combination. The unique feature of this system is the compact design that the shredder and the extruder are mounted on only one platform. Additionally, the shredder and the extruder can be operated with different rotation speeds. Further, the shredder is designed to convert the material in a very gentle way. The extruder can be equipped with or without venting. This is mainly depending on the condition of the input material. Due to the increasing demand of post-consumer materials, NGR has developed machines also for this purpose, up to a throughput of 2,500 kg an hour. These machines can convert materials with higher amount of impurities and higher contents of moisture. In 2010, we started to develop the Lsp Technology. The Lsp Technology was developed to convert all kinds of PET input materials to high-grade pellets. Already in 2014, we could install the first P-React for the fiber to pellets application. After successful commissioning of these lines, we were able to install many more Lsp reactors for various applications in inline or offline processes. Since 2017, we are equipped with the most important approvals for food-grade recycling. In 2020, we could install the first bottle-to-bottle line in Europe. PET recycling is going more and more liquid. In total, we sold 32 Lsp recycling lines in 12 different countries. The application ranges from pelletizing to inline processes and from non-food grade to food grade applications. What makes PET so attractive for the recycling and food packaging application? PET is many times recyclable and the technologies are available and proven. PET can be decontaminated and its mechanical properties can be improved back to virgin quality or even better during the recycling processes. The demand and the collection rate for PET bottles and trays continuously grow. Brand owners and governments in many countries set rules for a minimum amount of use from recycled PET in new bottles. The EU sets out minimum 30% recycled content target for plastic bottles in 2030 and a collection rate for plastic bottles of 90%. California is the first US state to require beverage containers to use 15% of recycled material in 2022 and increase to 50% in 2030. Most of the brand owners published to increase the recycled content in the PET bottles. Some of them would like to launch bottles out of 100% rPET in some European countries. Because it's not possible to show you the line in our demonstration center as a whole, I would like to guide you through a simulated version of the main components. We start the demonstration with crystallization and pre-drying before the material enters the feeding hopper and the extrusion system. After the extruder, the melt will be filtered and the IV is already measured here the first time. After the online viscosimeter, the material passes the melt pump and then the Lsp reactor for decontamination and IV lift. The vacuum and condensation unit is connected directly on the Lsp system. After the Lsp reactor, we have the final filtration system here and we have the online viscosimeter to measure the viscosity and control the viscosity. Then the material is crystallized and take a rest in the dealloidization system before it will be filled in the big bags. Now we are coming to the main part of today's webinar, the walkthrough of our bottle-to-bottle line in the demonstration center. Please follow me. Welcome to the lab and test center. Before we start a demonstration, we check the input material. The input inspection gives us accurate figures about the amount of impurities, the moisture content and the intrinsic viscosity. For the demonstration, we prepared typical European hot wash bottle flakes. From each big bag what we convert in our test center, we take a sample for the input inspection. Peter has already done some analysis of today's material. He analyzed the impurities, the moisture content and the intrinsic viscosity. Peter is head of the laboratory and he is responsible for all the chemical issues at the NGR, as well for the brand owner and food approvals like EFSA and FDA. Peter, can you show us the results of today's running material?
Yeah, David, as you mentioned, we did a roasting test at 220 degrees for 1 hour in order to find out contaminants, especially PVC, polyolefins. We measured the moisture and the intrinsic viscosity. Those are the results we found. We found a very low degree of PVC, which is typical for the European flakes quality. Some polyolefins and some PA and glue. We determined an IV of 0.75, which is typical for the bottle grade range as well. And the moisture was around 3000 ppm.
Okay, thank you Peter for the analysis. Especially the moisture content with 3000 ppm is very low on this material. Typically we specify a humidity less than 10,000 ppm, so the 3000 is a really low number. We are using a big bag empty station with an oscillating system for easy emptying of the big bag. The material will be transported from here to the crystallizer by the suction conveying system. The humidity is the biggest enemy of PET because it leads to high IV degradation during the extrusion process. To avoid this degradation, we pre-dry the bottle flakes before they enter into the extruder. Starting with the crystallizer, where we process the material for approximately 1 hour. The crystallizer is equipped with an educator to avoid agglomeration of the pre-dried material. The level sensor on the top of the crystallizer gives the signal for the start and stop of the material conveying. The crystallizer is equipped with a process filter to clean the air from oil and free-flowing dust particles. The filter can be cleaned and reused a couple of times. When the material is crystallized, it goes automatically further to the drying unit. The dryer works with dry air technology and has an absorption drying wheel for the dehumidification installed. The dryer is equipped with load cells to have permanent control of the filling level. Further, you can see and adjust manually the dew point, the temperature and the filling level of the reactor. If the material is finally dried, it will be transported to the incoming zone of the extruder. The pre-dried and already hot bottle flakes arrives by the tubes directly into the feeding hopper, which is mounted on the incoming zone of the extruder. The feeding hopper takes care for constant feeding of the extruder. The hopper as well as the tubes are thermally insulated to avoid condensation of water on the flakes. Further, you have the possibility to install any dosing unit for additives, either liquid or solid. The humidity is already removed. Therefore, we expect only minor IV drop during the extrusion process. That's why we can use a very compact and short single screw extruder. Melt filtration is in general a very important part in the recycling of plastic waste. The request on filtration fineness for bottle-to-bottle application gets higher and higher. In the moment we are in around 30 to 50 micron. If you would like to have a stable process, it is necessary to have a powerful melt filter available. Simon, show us how does a filter change works. We are using a 2-piston 4-cavity screen changer with power backflash technology in our demonstration line. To the hydraulic piston, the filter creates his own backflashing pressure for an excellent filter cleaning process. This leads to high numbers of backflashing cycles and long screen lifetime. The filter is equipped with the 4K75 technology. This means you have 75% filter area available during backflashing and screen changing. After the melt filter, there's the first online viscosimeter installed. This is basically an option and recommended when you have high fluctuation in the input material. If you want, you can set also an alarm if the IV runs below a specified number. Before the melt enters into the reactor, it passes through a melt pump and a diverter valve. The melt pump creates enough pressure to push the material forward into the reactor and takes care that the filling level in the reactor stays permanently constant. The valve is mainly used for start up the extruder and purge the extruder. As next, coming to the heart of the process, the P-react itself. As you can see, it's a very compact line with small footprint and a low height compared to other PET recycling systems. In order to keep the energy consumption on a low level, we use the already invested energy from the melt and just keep the temperature in the reactor. To the perfect insulation of the whole system, the additional energy investment is very low. The P-react mainly consists of a die plate package A vertical part and a horizontal part with integrated educator, a high-performance vacuum and condensation system, and an online viscosimeter with a smart software program. When the melt passes through the die plate, we produce a high numbers of very thin melt strands in order to maximize the surface area for the best cleaning performance of the melt. The task of the horizontal part is to renew the surface area and give the melt enough residence time to achieve the customer required IV. Depending on the final IV, the melt stays approximately 30 minutes in the reactor. To control the residence time of the melt, we use a patented level measurement system. Not only the excellent cleaning efficiency is unique, also the permanent IV control of this system. Basically, there are three parameters that have influence on the intrinsic viscosity: temperature, residence time and the vacuum. The first two we keep constant. We just use the vacuum to control the viscosity on a permanent constant level. If the IV goes down because of any reason, the vacuum gets automatically stronger to keep the IV on a permanent constant level. A further very important role plays the vacuum and condensation system. This system mainly consists of a two-step filtration technology, starting by a cold trap, followed by a non-moving bag filter, and ends by a high-performance vacuum pump. It is very important to condensate all the impurities before the gases entering the pump for a long lifetime of the pump. In the cold trap, we are working with temperatures below 0 degrees. We freeze and condensate out most of the impurities already in this filtration step. Depending on the input material, the condensate can be more liquid or dusty. Let's take a look. How does the condensate look like in the cold trap? As you can see, the condensate is in a really sludgy condition and it smells like ethylene glycol. The minor rest of the condensate is removed in the second filter step. The bag filters can be cleaned and reused a couple of times. Depending on the size of the machine and on the application, the complete vacuum and condensation system can be executed in a redundant version. Now, let's take a deeper look to the current running process and go over to my colleague Daniel Pichler. Hello Daniel, can you give us a short introduction of yourself, please?
Hi, I'm Daniel. I'm a process engineer at NGR and I'm at NGR now since 6 years.
Great, thank you. Daniel, how is the process running today?
The line was running very stable. We got an AV increase from 0.7 to 0.81, which means an AV increase of 0.11 points. The residence time it takes for such an AV increase is approximately 30 minutes.
Excellent, thank you. Daniel, what is, in your opinion, the main advantage of the Lsp technology?
The main advantages are the high decontamination efficiency, which allows to produce food-grade pellets, and on the other side, the rapid IV increase, which means you can produce a customized IV within very narrow fluctuations.
Thank you. And why do you think is the P-React the key technology for the future?
due to the fact that we have this very good decontamination and high AV increase, that allows a very wide spectrum of input material to be processed and achieve good end quality, basically.
This is really unique compared to other systems. Daniel, and how stable is the process running today? Can you show us a trench profile?
As you can see here, the outlet IV meets the required IV very well. We only see very narrow fluctuations of 0.01 plus minus.
Excellent. This meets excellent the set point from the line today. Daniel, do you have also some results from a trial what we run in a production plant?
Yeah, as you can see here, the B star is below 0 at all the times with a still very high L star, and the volatiles such as benzene and AA are very low with 0.8 in AA and 7 ppb in benzene.
So the very low benzene is really an amazing number. This is really an unique. Can, in your opinion, the low benzene value have an extra value for the customer, and when yes, why?
Yeah, as you know, benzene is a cancerogenous molecule, so therefore you want to have as small amounts as possible inside the product.
Okay, sounds very good. Thank you, Daniel, for the information and for your time.
Welcome.
Now let's continue at the outlet of the reactor. The melt is discharged by a melt pump and pass the second melt filter. This one is necessary to meet the customer requirements on the final melt filtration. After the second melt filter, there's the online viscosimeter installed, what we are using for the IV control in the reactor, what I have explained already before. The process from here is very flexible again. Most of the bottle-to-bottle recycler would like to have crystallized pellets in a spherical shape. Therefore, we are using an underwater pelletizing unit with inline crystallization system. Simon is cleaning the die plate and starting up the pelletizing unit. The cut pellets will be transported by hot water as quick as possible to the centrifuge, where the pellets will be separated from the water. The energy of the pellets will be kept in order to use it for the crystallization process. The PET pellets coming from the centrifugal dryer enter the crystallization channel in an amorphous state. In a couple of minutes, the pellets are completely crystallized along the vibration channel. The pellets are in a spherical shape and fits the size according to customer or brand owner specification. These are first-class decontaminated and homogenized food-grade pellets coming out of the liquid state polycondensation process. At the end of the channel, the temperature of the pellets is approximately 150 degrees. With this temperature, the pellets will be transported to the dearidization system to meet the AA level of less than 1 ppm. Due to the high mobility of the molecules in liquid states, the decontamination performance is enormously high and the viscosity reliable stable. As you can see in the chart, all the chemicals defined by the EFSA are close to 100% removed. After the crystallization process, the pellet takes a rest in the dealloidization system to achieve the customer requested AA level. To the fact that the pellets enter the dealloidization system already with 150 degrees, the additional energy investment is very low. After the dealloidization and before filling, the pellets will be chilled in a cooling hopper. The hot air which comes out of the cooling hopper will be used for the crystallization process at the very beginning. This leads to a closed loop and energy efficient process. Finally, the pellets arrive at the filling station. In our case, it's a double big bag filling station with weight measurement and automatic switch between the big bags. The pellets are in a good and hand-warm condition. Before we are going back to the lab and check the quality of the today produced material, I would like to give you a short insight about another option what you have with our P-React system. To the fact that the P-React provides constant and homogeneous melt quality, constant melt pressure and constant throughput adjusted by the melt pump, it is a perfect option to directly install an injection molding machine after the P-React and use the available melt for the direct processing and save energy, space and material logistic for an additional remelting process. Together with our joint partner Husky, we have already realized a prototype for bottle flake to preform technology. The machine for direct injection molding application is available for trials in Canada. If you are more interested in this application, we would like to invite you for a separate webinar of injection molding process with the Lsp Technology by the end of September. Welcome back to our laboratory. Peter has already analyzed the today produced material. He analyzed the intrinsic viscosity and the LAB color values. Peter, during the demonstration we saw an intrinsic viscosity of about 0.8 deciliter per gram on the HMI measured by the online viscosimeter. What have you measured in the lab? Can you confirm this number?
Yes, David, I can confirm this number. That is one sample of the pellets, and in the lab we measured several of them and reached an average value of 0.80, which coincides perfectly with the online IV measurement.
Okay, thank you. As you know, the color values are also very important for the bottle-to-bottle recycling. Have you also analyzed the LAB color values? Especially we are interested in the B and in the L star.
Yeah, color is important in the bottle grade sector, so we analyze color as well. We found a rather high value of 69.6 for the L value and a B value of 1.9, which is absolutely in the range.
These are excellent numbers, yes. So the brand owners mostly expect a B value of less than 3. So with 1.8 we are in a good range to fit the request of the brand owners. Okay, thank you very much for your time and the analysis, and have a good day. Now we will continue with the interview of one of our customers, Altech from Japan. He is invested in a bottle-to-bottle application. Hello, Mr. Katayama-san. It's a pleasure for me to have Altech for an interview available today. Thank you, Mr. Katayama-san, for your time and providing us with the interview. I also would like to thank the entire Altech team for the trust and cooperation with NGR, as well the investment for a bottle-to-bottle line for your plant. Now I would like to hand over to you, Mr. Katayama-san, and ask for an introduction of yourself and a short history about the company Altech.
Sure. So first of all, thank you very much for inviting me for NGL seminar today. And Altech has a two cap on our head. One as a trading company. We are registered in the first place in Tokyo stock market. And our revenue is around $200 million as a group. We are representing 170 industrial machines from overseas countries, which covers many industries in the market. And I'm in charge of a polymer process divisions, which is one of the 8 divisions of Altech, dealing with the plastic converting machines, including NGL recycling system. So we have another cap on our head as a preform manufacturer. We have a facility in 5 locations in Suzhou, Guangzhou, Wuhan, Chongqing in China, and Fukui in Japan. And in those facilities, we are producing more than 2 billion preforms and 500 million caps annually, which is quite a lot of numbers because we are dealing with the Chinese market. And our preform are mainly used for aseptic filling, which requires very, very high quality demands. And we also have a joint venture with Coca-Cola China as their first aseptic bottling plant in China. So our customers are major brand owners such as Coca-Cola, Suntory, Danone, EA Kelly, Otsuka Pharmaceuticals, blah, 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 a lot. And in our Fukui, besides our preform facilities, we installed the NGL P-gram in order to manufacture preform using bottle-to-bottle recycling material in Japan. And we are very excited to start production in this autumn. And our production line is 2 tons our pellet, pellet making systems.
Thank you for the introduction. Altech seems to be a very innovative and huge company with various business segments. Further, I would like to ask you a general question regarding the PET recycling market in Japan. What are the biggest challenges in the Japanese bottle-to-bottle recycling market? And how is the current collection rate in your country?
PET bottle recycling status in Japan is just, we have a very good ratio, like 93% collecting ratio. And 40% are exporting, mainly to China and overseas countries, and 60% are recycled in inland. And today's situation, as of 2020, we have only 12%, which is equivalent to 74,000 tons converted to bottle, from bottle recycled material. And 20% is converted to sheet, and 10% to fiber and filaments. That is the situation in Japan. And today, Japan beverage owners are very keen to establish bottle-to-bottle recycling, kind of horizontal recycling flow, in order to establish a circular economy in Japan. For instance, Coca-Cola said 90% by 2030. Suntory said 100% by 2030, not 1930, 2030. And it depends on the brand owners how much they are using bottle-to-bottle recycling. But as a conclusion, Beverage Association, Japan Beverage Association announced 50% of a PET bottle will be made by bottle-to-bottle recycling by 2030 as an industry target quite recently. So which means 12% of today, which is equivalent to 74,000 tons, is going to be 50%, which is 330 kilotons in 2030. Means 5 times bigger from today in bottle-to-bottle application. That is the status in Japan we are facing, we are moving.
Thank you for the interesting answers. These are great figures for the collection rate of PET bottles in Japan. Obviously, Japan is a model country for the PET collection systems. The next question what I have for you is about your investment in the recycling plant. What are the main reasons why you choose our liquid state polycondensation systems for your recycling plant?
So first of all, safety as a food package, we have to think about. So decontamination capability is most critical and necessary element for both volatile and physical toxic contamination. An IV increase in faster production speed is required. And at the same time, IV stability has to be kept in target IV setting. Of course, color and transparency in end product has to be kept, and acetaldehyde has to be less than 1 ppm if you would like to use, bottle in water application. And the why I choose, Lsp Pigran is one of the reasons is I love real-time IV monitoring system of Pigran. So which is very strong system in order to keep quality management in high productivity. So the last but not least, cost performance is very important element as well. So there's many reasons we chose Lsp Pigran. So after confirming all performance of Pigran in Fukui, there's another reason we would like to challenge Flake to preform line will be as our next challenge. That is one of the reasons why we choose Lsp because of this, extension capability. Because I believe this will be, this will achieve, better cost performance, even better, quality. So Pigran deserves to connect injection system by accumulation capacity and faster IV increasing, capability, and of course compact design.
Thank you, Mr. Katayama-san, for the detailed answer, what I completely agree. These are very promising facts, what confirms that we are on the right way with our technology. Now we are already at the end of the interview. I have to say thank you for your time and for your answers. I wish you and your team all the best and success with your new bottle-to-bottle recycling line. Take care and goodbye.
Okay, thank you very much. We're very excited to have your system. Thank you very much.
Now I have to say thank you for your time and interest in our webinar today. I hope the webinar could give you a better insight of our PET recycling technology and meet your expectations. The live chat will remain open for the next 30 minutes. Please use this opportunity to write us your questions. We try to answer them with our best knowledge. Now, I look forward hearing from you and work with you on many exciting projects. Thank you very much and goodbye.